last time. So we were talking about finding zeros of polynomials, right? And this is all related to that second assignment. So this is, what is this, 5? This is 5.8 practice 1 is what this is. For the finding zeros assignments, what we're talking about. So see if we can remember some of this stuff. If we're given that 2 minus the square root of 5 and 1 plus 2i are zeros of this polynomial, they want us to find all the other zeros. Okay, how am I going to do that? How many should I get total for this polynomial? Should get 6, right? They've given me 2. How am I going to find the rest? Okay, good. Conjugates, right? So we know. Now, what about this first one here? This goes back to that rational root theorem, right? So I know that if I have rational coefficients, which I do in my polynomial, then I know that irrational zeros that come in this form, where it's going to be some integer, or actually that'd be an integer, some rational number plus or minus some rational number times a square root, right? Those always come in conjugate pairs. So what's going to be the other zero that goes with this one? Guaranteed. 2 plus the square root of 5. Okay, good. Okay, how about we're given the zero 1 plus 2i? What do we know about that one? 1 minus 2i. Okay, so we've got 4 known zeros, but we got to find the other 2. Now I have no clue about the other 2 though. Those I have to go find. So what am I going to do? Okay, good. So we can associate each of those zeros with factors. And what's the recipe? The factor that goes with it, if k is a 0, what's the factor? X minus k, right? So then here we're just going to end up with, if this is the 0, then x minus that 0 is my factor. If 2 plus the square root of 5 is a 0, then x minus the quantity 2 plus the square root of 5 is a 0, and so on and so forth. I've got x minus 1 plus 2i and x minus the quantity 1 minus 2i times, my function is going to equal the product of those 4 factors plus some other factor. Now, what's the degree of that other factor going to have to be? It's going to have to be 2, isn't it? Because the total degree of the polynomial is 6. So I know that's going to be quadratic, right? So if we're thinking strategically then, if I could just figure out what this other factor is and it's quadratic, I can find the other zeros because I can solve any quadratic equation, right? With the quadratic formula, if nothing else, it always works. So by finding what this factor is and setting it equal to 0 and solving, I could fill in the blanks for the other 2 zeros, right? Okay, so now how are we're going to multiply all these things together though, right? This is that trick I showed you, that regrouping trick. This is such an awesome trick. So if we regroup these, right, I'm going to go ahead and distribute the negative. Okay, so that's going to become x minus 2 plus the square root of 5, x minus 2 minus the square root of 5. And then I regroup those. So I've got x minus 2, the quantity x minus 2, plus the square root of 5, and the quantity x minus 2 minus the square root of 5. Distribute the negative and regroup. So it looks like conjugates. Right now it looks like I've got a plus b times a minus b. Everybody see that? Okay, same thing over here. I'll distribute the negative and then regroup. Distribute the negative and then regroup. So I've got the x minus 1 grouped together in both of my factors. And then it looks like a minus bi times a plus bi. Easy products to calculate, right? So if we multiply these together, well, we know that a plus b times a minus b is a squared minus b squared, and the square root of 5 squared is just 5, right? Okay, same thing here. I've got a minus bi times a plus bi. When I multiply complex conjugates, I get a squared plus b squared, right? So there it is, x minus 1 squared plus 2 squared. And I can simplify that stuff pretty easily. That's just giving me x squared minus 4x plus 4 minus 5, which I can simplify. This gives me x squared minus 2x plus 1 plus 4. And if I combine like terms, I'm just getting the product of those two quadratic polynomials. Now that's kind of a pain to do. I mean, I've got to FOIL all that stuff out. I mean, that's not easy, but we can do it, right? If I multiply all that stuff out, you like my color coding here? Yellow and green makes blue, right? So how about that? It's pretty good. So isn't that right? Actually, I got it backwards, didn't I? It's yellow and blue makes green, isn't it? Kind of got it backwards. All right. Maybe I'm not so clever after all. But if I FOIL all that stuff out, we're not going to go through the hassle of doing that. You guys can all do that. Distribute the x squared, distribute the negative 4x, distribute the negative 1, add like terms. You guys can do that. I get this blue quartic polynomial, okay? So then I know that my original polynomial is equal to the blue one times the one I'm trying to find. So now is where I divide, right? So I would just go through and solve for this quadratic polynomial by dividing the white one by the blue one. And if I do that, you could do that too. That's just long division, right? And you guys have done a ton of long division. You'll get practice. If I do that, I end up with x squared minus 1. So now what are my other two factors? If I set that equal to 0 and solve, what do we get? 1 and or rather two zeros, 1 and negative 1. Exactly. So we got it. Okay? Does that make sense? Okay, good. This is pretty good stuff, isn't it? I mean, we're getting, sometimes it's kind of nice to look back. If you think back where you were a couple of years ago in math, you know, and you think you can do a pretty real self-evaluation of where you are and think, man, this is like my math ability, it just continues to grow and it almost accelerates. As you get into more advanced classes, you pull more things together and it's almost like you increase your knowledge even faster. I mean, you really start cruising when you get to calculus. Okay, so rather than going through a bunch of other examples, what I want to do is I just want to show you some other ways that we could reorganize that same question and ask essentially the same question in different ways. So another way the same question could be asked would be to say something like this. Given that these two zeros that they gave us, write the function as a product of factors. Okay, isn't that almost exactly the same problem? I mean, we've got everything looks the same. We've got these four known zeros. We have to turn those into factors, right? Which we can do. But then in order to find the other two, we've just got to go through the whole process we just did, right? We've got to say that our original polynomial is equal to the product of the yellow simplified factor times the green, which gives us the blue, right? Same stuff. The only difference is at the end, rather than writing the zeros, we're just going to factor that other expression, that x squared minus 1. It's exactly the same question, isn't it? It's just asking for a slightly different expression of the answer. This time we're writing them as factors instead of zeros, right? So it would just look like this. If we're writing them, and I think it wants them written, it would have said something like, write those as irreducible quadratics or as linear factors. So in other words, they don't want factors that are going to involve square roots in them. They want it to be written like if we were going to try to factor a trinomial, we would say there are no factors if I couldn't find magic numbers so I'm going to end up getting rational zeros, correct? I mean, there are factors, but if the factors involve square roots, we don't even look for them, right? We say those are too hard to find and there are no convenient factors. So the exact instructions, I believe, would have said something like, write it as a product of linear or irreducible quadratic factors. And so when we take these weird zeros and we put them together and we create the quadratic factors that they would have come from, those look better. I don't have any square roots in them anymore, right? And so our final answer would just look like this. There's our yellow factor that we built from the 2 yellow zeros that we started with. We've got the green quadratic factor that we built from our imaginary zeros. And then we've got this x squared minus 1 that's a difference of squares that we can break down conveniently. Okay, so that's what our answer would look like. Okay, give me thumbs on that. How we doing? Okay, good stuff. The other way we could do this one would be to say something like this, like write the polynomial. So what if they gave me the same information? Say they gave me slightly different information. They're telling me the leading coefficient is 1. They're telling me that 2 minus 5, square root of 5 is a 0, 1 plus 2i, and they're telling me this time, they're giving me the 1 and the negative 1 also are known zeros. Then they would say something like, write the simplest possible polynomial that comes from that. Well, that's just going to be the product of this, the factor that comes from this 0 and its conjugate. So the same 2 yellow factors that we had before, the same 2 green